Welcome to the section on calculators and trigonometric functions of an acute angle. I will mention later why it is an acute angle and not obtuse angle, as I mentioned later. Using calculators, we'll figure out how to convert from degrees, minutes, seconds to decimal degrees and the other way around. And then just to mention, older scientific calculators, you would have to work backwards when you use when you want to determine cosine or sine of an angle. I don't have an older scientific calculator here, so we'll just look at the one that we're expected to have, the graphing calculator, where it's straightforward, cosine of 37.8 degrees, for example. And then finally, we're going to look at inverse functions and the inverse sine, inverse cosine, inverse tangent are inverse functions in the same sense as the square root of x and x squared, the inverse function of each other, and the natural log of x and e of x are inverse functions of each other. So for example, sine of an angle will give us the opposite over the hypotenuse, while the inverse sine of the opposite of the hypotenuse is going to give us the angle. Notice that, as we know, cosecant, secant, cotangent are the reciprocals, not the inverse functions. Okay, let's get started here. First of all, we're going to add angles in degrees and minutes. And when we do so, we add degrees. So we're going to have 51 plus 37, which is 88 degrees. And then we're going to have 55 plus 45 minutes, which is 100 minutes. However, there are only 60 minutes in a degree. So for each 60 minutes, we'll bump up the degrees by 1. And then, of course, the minutes down by 60. So this one is 89 degrees and 40 minutes. Subtract 51 minus 37 is going to be 14 degrees. And then 12 minus 45, well, what we would have to do is we have to borrow, so 12 minus 45 here on the minutes. What we have to do is we have to borrow a degree, so 13 degrees, which bumps this one here up to 72, as we had 1 degree, which is 60 minutes. So 72 minus 42 then comes out to 27 minutes. Convert from decimal degrees to degrees and minutes. 16.25, so that's 16 degrees. And what are we going to do with 2.25? Well, we do 0.25 times 60. And when we do that, we come up with 15 minutes. And maybe I will actually leave it like this here. Oops, that was a little bit too much. 16, and what did I have? 0.25 times 60, and then I will rewrite this here, and it will be 16 degrees and 15 minutes. In this case, I could have actually done it quicker and say, well, 0.25 is a quarter of a degree. That means a quarter of 60 minutes. Well, it needs to be 15 minutes. Just like this one here, 18 degrees. 18 degrees. 0.75 is 3/4 of a degree, and 3/4 of 60, of course, is 45. To do this a little bit slower, it would be 0.75 times 60, and of course 0.75 times 60 is 45 when you do that on the side. The other way around, what we would have to do here is 51 and then plus 55 over 60, and then we're going to come up with And let's do this on the side here. For now, 51 plus 55 divided by 60. So 51.92 rounded degrees. And here we have 37 plus 45 divided by 60 degrees. So we're going to come up with 37.75 degrees. How's it look on the graphing calculator? Let's do that. And actually I have to find my graphing calculator. I think I hit it. Let's try again. There it is. Okay, that's still from last session. Let's see. The numbers that we were looking at here were 16.25, and it needs to be converted to degrees, minutes, and seconds, and that's under second angle and the DMS. And there it is, 16 degrees, 50 minutes, 0 seconds. That's what we had. 18.75, as I had shown, was 18 degrees and 45 minutes. So again, we do this. And there it is. And the other way around, 51 degrees, 55 minutes. See, typing in a number like this here actually lasts quite a while, so throughout the course we'll try to stick to decimal degrees, but this is an introduction to degrees, minutes, and seconds. And then it's relatively easy. Just hit enter and it automatically gives you the decimal degree. And finally 37 degrees and 45 seconds. Comes out to 37.75, just like we had determined. Okay, find 37.8 degrees, cosine of 37.8 degrees, tangent of 58, and so on. So I'm going to go back to the graphing calculator and determine these. Clears here. Cosine of 37.8, as I said on a graphing calculator, is straightforward. 0.790, I guess 3 decimals. Tangent 58, and as you can see, this is going to be a little cumbersome to put this in. Would have been quicker if I had just typed in tangent of 58.75 instead of this one here. And there's the answer. I better write these down here just before we go back. And let's see, 1.648, I guess. Sine squared, 14 degrees, and that's squared. Here's the question, what did the square do? Did it square the sine, or did it actually square the 14? Well, let's do the following in order to make really sure. Parentheses, sine 14, parentheses, parentheses, and now a square, and now we definitely know it will square the sine, and indeed that's the same, so you can write it either way. I tend to write it the second way because that way it's really apparent that the sine is squared, not accidentally the 14. And the last one that I had on here, actually, let me write this down here, 0.059, I guess, two significant figures. And then I have secant of 78 degrees, which of course is 1 over 1 over cosine of 78 degrees. Hit enter. 4.81 or just 4.8. Okay, I'm going to go back and write these down. Let's see, 0.790. There we go. Okay. Next topic, memorize approximate values. I actually did that in the last section where I showed how to do that on the graphing calculator. But what we did in the last section is we determined the exact values, which were 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1 backwards for the cosine, and then for the tangent was 0, 1 over square root of 3, 1, square root of 3, and undefined. Here is the approximate values. We already know that we're going to get 0 here anyway, and here 1, and here we're going to get 1, and we get 0 here, and here we're going to get 0, and here we're going to get undefined. So the values in between, well, this here will be 1/2, so 0.5. We also know that as well, and 0.5. But we will look at the graphing calculator and test these values. Here we know square root of 2 over 2. We could possibly do that in our hand. So we'll have to have it memorized anyway. For the tangent here, we know that this one is going to be 1. Now let's go to the graphing calculator and actually do these. And I'm pretty much going to do it pretty much the same way as the last time. So I'm going to define 0 and 30 and 45 and 60 and 90 as a list 1. Then I'm going to go to Stat, Edit, and then actually I want to get rid of these lists here. Okay, that's good. And now I'm going to go in here and I say that the list L2 equals sine of list L1. There, and there it is, 0, 0.5, 0.707, 0.866, we may want to memorize them 2, 3 decimals, and 1. For L3, cosine of list L1, there it is, backwards, 1, 0.866, 0.707, 0.5, and 0. For the tangent, let's see if this will work, because we should get an undefined for the last one, second one. Please enter up. Exactly. Didn't like that. So what I will do is, all right. Clear this. So what I will do for the tangent is I will get rid of this value here. And now we'll do this again. Tangent L1. And there are the values. 0.577, 1.73. Just to show you for the tangent for very large values, tangent of 90 degrees will be undefined, as we know by now. How about tangent of 89.99 degrees? And you'll see that this one is a pretty large number. Tangent of 89.1, 2, 3, 4, 5, 6. And you will see that this is a very large number. So yeah, the closer it gets to 90, the closer it seems to get to infinity, and that of course is undefined. Respectively, as we have seen, the tangent is actually negative in the second quadrant, so as it goes from the first quadrant to the second quadrant, we go from positive to negative. And so is it positive infinity or is it negative infinity? In any case, it's undefined. Okay, let's go back to Word and plug these values in the table here. So this is 0.707, memorize it, 0.866, memorize it, 0.866, 0.707, and this one is 0.577, and this one is 1.732. I have to admit, I actually did cheat on these two values here, this one and this one. I have to remind myself but that they are 0.577 and 1.732. Okay. Find acute angles. Tangent theta equals 3.152. In order to figure out theta, we have to use the inverse function, so we have to take inverse tangent of 3.152. In the back here, I put also an approximation sign, which means I'm going to make an estimate for that. To me, notice that. In fact, let me get this big down here. The 3.1 here is past 1.7, so it has to be between 60 and 90 degrees. Just a guess here, 70 degrees might be the answer. And then we'll see on the graphic calculator. In order to figure out sine A equals 0.3733, what do we do is we determine inverse sine of 0.3733, which is between 0 and 0.5, so the angle should be between 0 and 30 degrees. So I'm guessing 20 degrees. Secant B equals 1.0768. Well, secant B is the same as 1 over cosine B. So that means that cosine B is the same as 1 over 1.0768. And that means that B equals the inverse cosine of 1 over 1.0768. Top of my head, 1 divided by 1.07 comes up to roughly 0.9 or so. So we're at between 0.866 and 1, so again maybe around 20 degrees or so. Cotangent C equals 0.0975, which is the same as 1 over tangent C. So that means that tangent C equals 1 divided by 0.0975, and therefore tangent is the, C is the inverse tangent of 1 divided by 0.0975. For the last two, as I determine the secant and the cotangent, I have to express it in terms of cosine, respectively, tangent anyway, because it's the only thing that my graphing calculator accepts. Here what I come up with, 1 divided by 0.0975 is roughly 10, which is a pretty large value for the tangent. So here I'm guessing maybe 85 degrees, maybe even larger. Okay, I'm just going to write down my estimates, 20, 20, 85, and then I'm going to go to the graphing calculator. Okay, and that's how we type it in. Inverse tangent, so secant tangent, of 3.152, 72.7 0.40. It seems like we need 4 significant figures. That's pretty close to my estimate of 70 degrees. The next one is the inverse sine of 0.3733, 21.92. That's pretty close to my estimate, or my estimate of 20 degrees, pretty close to that. The next one was inverse cosine of 1 divided by 1.0768. My estimate was 20 degrees, 21.77 degrees. Here I may want to show, going backwards to make sure that this is the right number, I determined the secant of 21.77 degrees by doing 1 divided by cosine of 21.77 degrees. And then indeed is the original 1.7068 that was given. And the last one is inverse tangent of 1 divided by 0.0975, 84.43 degrees. Again, pretty close estimate that I had. Okay, going back to Word, I'm going to plug in these numbers. So this one was 72.40, 21.92, 21.77, and 84.43. And with that, I conclude this lecture. Here's a short amendment to this lecture. I actually had forgotten to mention why it says find acute angles. Let's look at the sine A equals 0.3733 as well as the tangent theta equals 3.152. For the sine A equals 0.3733, we come up with that A equals 21.92 degrees. An obtuse angle would be, for example, the supplement to that, which is 150 8.08 degrees. Watch in just a moment what happens when we plug sine of that supplement into the graphing calculator. And then we're going to look at, for the tangent here, we're going to look at not 72.40 degrees, but we're going to look at 252.40 degrees and take the tangent of that. So let's go over to the graphing calculator. Okay, clear this. Okay, I said a moment ago, tangent of 252.40 degrees, and we come up with 3.152, which is the same as tangent of 72.40 degrees. Whoops, forgot the decimal. 3.152. What if we go backwards? That means we take the inverse function. So we're going to do inverse of 3.152, 399, and so on. Both of these angles here, 72 and 252 degrees, should be correct. However, the graphing calculator only gives back the acute angle, also called the reference angle. So keep that in mind. The same thing happens for the sine. I said sine of the supplement 158.08 degrees, and we come up with 0.3733, and sine of 21.92 degrees, 0.3733. What if we go backwards? Inverse sine of 0.3733. Well, we only come up with the acute angle of 21.92 degrees. So keep that in mind, that when you do the inverse function, it only gives you the acute angle or the reference angle, even though there are other angles that work as well. In this case, the supplement angle of 158.08 degrees. And that's all that I meant to mention as an amendment to my lecture, where I forgot that as well.